Hello, my mathematicians. We're back for another edition of 7th grade mathematics at Brent International School, Manila. And today we get to talk about adding rational numbers. Remember, rational numbers are all numbers that can be written as a fraction with integer numerators and denominators. That includes terminating decimals like these terminating decimals. So let's get to it. First, we're going to work with decimal numbers that have the same sign. I want you to fill out these notes at home because it's so exciting. So if the decimal numbers or if the numbers have the same sign, then you keep the sign, you line up the decimal, and you add like normal. So let's give it a try. These two are both positive numbers. They're both hills. So I'm going to keep the sign, line up the decimal, and add like normal. Here we go. Give me orange. Let's do orange today. And because this number is already here, I'm just going to bring this 9 and 6/10 right underneath it. Boom. I can add a 0 at the end of any decimal number and it doesn't change it. Very cool. Very, very cool. So now I get to keep the sign. They're both positive, so my answer is going to be positive, and add like normal. You can do it any way you want. You can do exploding dots way, or you can just do traditional way. I'm going to do traditional way. I add up the hundredths place and I get 5. I add up the tenths place and I get 13, but I got to explode 10 of them and bring one up there. And I have 1 and 2 is 3 and 9. I have 12 wholes. My solution, 12 and 35 hundredths. Beautiful. And there you go. That's how we add decimals with the same sign. Please give it a try right over here. Number 2. Do that on your own. I'll check it in class. Okay, I'm going to pause for a second and move the screen. So let's continue adding rational numbers, decimal numbers. So look at these two now. These have different signs. We have a positive, we have those piles, and then we have the opposite. We have holes here. So piles and holes, if you have different signs, you're going to keep the sign of the larger absolute value. So if I look at 7 and 875 thousandths and negative 2 and 275 thousandths, this has a larger absolute value, 7 and 875 thousandths. So I am going to keep the sign of that, and then I'm going to line up the decimals. Let me line them up. And I have 2 and 275. And then I subtract, or I add the opposite. Add the opposite. That's all this is. Subtraction is just adding the opposite. I subtract the smaller absolute value from the larger one. So now I do a little subtraction. 5 minus 5 is 0. 7 minus 7 is 0. 8 minus 2, 6. 7 minus 2, 5. And because this has a larger absolute value, my answer is positive. And there you have it. 5 and 6/10 or 5 and 600 thousandths is our solution there. Why don't you give this one a try? Check to see which one has a larger absolute value. Your answer is going to be a negative number this time. And then you'll subtract 3 and 25 hundredths from 8. All right, give it a try, and we'll check it in class. And here we go with fractions. Fractions, when we are adding fractions, remember, let's type this in here. When you add fractions, adding fractions. First step, find a common denominator. Second step, change numerators. I think I spelled it right. To make equivalent fractions. And 3, add numerators only. 4, keep denominator. Alright, that's just a brief way to show you or explain in words what I'm going to do here. Well, this is a beautiful thing. This already has a common denominator of 9, so I don't have to find one. It's already found for me. So I don't have to change numerators because I didn't change denominators. And now all I have to do is add numerators only. So this really becomes 2 plus 5 over 9. Okay? We just combine these top two, and what we have, the numerators, not the top two, and what we end up with is 7 over 9. 7/9. Easy peasy. And just like before, if it has the same sign, you keep the sign. Over here, same sign, I keep the sign. I'm going to do this one with you. So we have the opposite of 1/8 plus the opposite of 5/8. So we know our answer is going to be the opposite of something, and we're going to take 1 plus 5, so it's the opposite of 1 plus 5, which is 6, and we keep the denominator. So the opposite of 6/8. Well, I need to simplify that. I'm going to divide both by 2. The greatest common factor is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So I have the opposite of 3/4. So same sign. If it has the same sign, common denominator already, just add straight across and keep the signs. Let's look at what happens when they have different signs. Same rules apply as over here. You keep the sign of the larger absolute value. So we have to ask ourselves, is 3/7 larger or 5/7 larger? And 5/7 is larger absolute value. This is positive, so our answer is going to be a positive number. Okay? And then I take the larger absolute value, 5/7, and I subtract it, or I subtract, ooh, that's supposed to be a 3, sorry. I subtract the smaller absolute value from it. So now I have 5 plus the opposite of 3 is 2/7. And I don't really want to think of subtraction anymore. I always want to think of adding the opposite. So I'm adding the opposite of 3. The opposite of 3 piles is 3 wholes. So I have 5 piles plus 3 wholes. That gives me 2 piles, 2/7. Okay, try number 4 on your own. Try number 4 on your own. Which one has the larger absolute value? And then just go ahead and add the opposite. All right. Let's take some that have different denominators. We don't have a like denominator. They're not like. So we have to find a common denominator. There are 2 ways to do it. I'm going to show you both. Way number 1 is to list the multiples of both. So multiples is skip counting. 3, 6, 9, 12, 15, 5, 10, 15. And then whichever one is in common, you want the least common one, that's your new denominator. So my new denominator is 15. Now remember, I have to write an equivalent fraction to 1/3 with 15 as the denominator. And because I multiplied the 3 times 5 to get 15, I'm going to multiply the 1 times 5, or the opposite of 1 times 5, and that's going to give me the opposite of 5. And then I'm going to add, I did 5 times 3 to get 15, so I do 4 times 3, that gives me 12. So now I have the opposite of 5 plus 12. Well, 12 has a larger absolute value, so it's going to be positive. And then I have 5 wholes, 12 piles. That's going to leave me with 7 piles over 15. I keep the denominator. 7 over 15. I know this is a little challenging, but it works every time. The other way you can find a common denominator, I'll show you over here, is to multiply the two denominators together, and you get 8. Right? 2 times 4 is 8. And then you can cross multiply to write an equivalent fraction. So 4 times 1 is 4. 2 times the opposite of 3 is the opposite of 6. So what I'm left with is 4 plus the opposite of 6 over 8. 4 plus the opposite of 6 over 8. which is the opposite of 2 over 8. Simplify is the opposite of 1/4. The trouble with this way, ladies and gentlemen, is if you just multiply denominators to get the common denominator, your solution will not always be in simplest form. So you have to simplify. If you do it the other way and find the least, remember the least common multiple between the two denominators, then your answer will be in simplest form. That's the skinny on adding rational numbers. I'm going to stop there, but I want you to try to do these last 4 at the bottom and fill in these 2 that I didn't do. Any ones that I did not show you, I want you to try at home, and we'll check them at school. Just a quick hint on these. There's a couple ways to do them, but the easiest way usually is to change them to improper fractions. All right, we will check these and go over these at school because I'm over my 10-minute time limit and I don't want to waste your time. Excuse me, it's not a waste of time. I don't want to talk your ear off anymore. Anyway, ladies and gentlemen, once again, I conclude another edition of Rational Number Operations. See you tomorrow.